Page 11. At the bottom, we're just going to balance first thing first. Page 11. Page 11. What running game is this? Oh, even scarier. Yeah. My only experience with underarm cleats, Under Armour, is that they rip out.
Really?
The whole,
Except for cameras.
like, they were, but they ripped out. The circle, literally the whole circle ripped off on the inside. But you don't run the 100. Well, not really that more. You don't run the 100, and you're never on a curve on a relay. That's what happened. All right, so here we go. That was all on tape. I hope whoever's watching this enjoyed that conversation. So we are going to balance S plus O2 goes to SO3, correct? We're not going to spend very long on this, so hopefully it goes all right. S plus O2 goes to SO3. It's a 2-3 swap, is it not? All right, hopefully you are good at balancing. If you're not, well, it might be an interesting test for you. 2, 3, 2. Sound okay? Okay, now look at the screen. I'm asking you to go from liters to liters. There's a short way to do this and a long way to do it, and we're going to teach you the long way first. Let me put this red line. Remember, you have to cross that red line. And if you look at me, liters go here, liters go there. We are going to go down, then we're going to go over, and then we're going to go up. So how many parts of the picket fence is that? How many lines? 3. So 1, 2, 3. And I'm just going to follow the same process I've been doing. I'm going to take my given and put it in the top left. If 12 liters of O2, and then the unit on the top left always goes to the bottom right, every single time. So I'm going to put liters of O2 right here. Anytime I've been doing liters since yesterday, I put what number? 22.4 every time. And that's always per 1 mole. Show Tyson where we got that number, would you? 1 mole of O2. All right, and if I have the unit on the top left, I have the unit on the bottom right. So that's mole of O2. Then I have to go to the end. What am I solving for? Liters of what? SO3. So look, I have liters of SO3. Anytime I have liters, it's per what number? All right, 1 mole on the bottom. But what's on the, what number here? 22.4. And if I have this unit here, then I have that unit there, and it's mole SO3. And then I can find those numbers up here. There's a 2 in front of the SO3. There is a 3 in front of the O2. And then I'm ready to go. Will you all please look at the screen, though? Because you can save yourself a lot of calculating. In this first step, we divide by 22.4. In the last step, we multiply by 22.4. That means that mathematically, these steps will cancel themselves out. Are you okay with that? Mathematically, they're canceled out. So math-wise, we're just taking 12 times 2 and dividing it by 3. So that's 24 thirds, which is 8. Are you okay with that? All right. Now, liters to liters should always, technically, should always go down, should always go over, and should always go up. But there is a shortcut. You can just go straight across. What's this step right here? Ratio of coefficients. What are these numbers right here? That's the ratio of your coefficients. So if on these you want to go for the shortcut, you put the moles of the given on the bottom, moles of the wanted on the top, and you can just go from there. So let's go to the homework and do one the short way. Now, if that didn't make sense to you, then don't do it that way. Do it the long way. All right, this is number 55. This is like the 10th time we have tried to balance the combustion of propane. So 55, I'll help you. It's C3H8 plus O2 goes to CO2 plus H2O. It is a combustion reaction. See if you can balance that on your own. We have done this exact one before. If you need to look, you might be able to find it. Nice job. Yep. All right, here we go. This one is reducible, so maybe some of you have half of these numbers. But if it's a combustion, you start by putting a 2 right there. You then take 2 times that number, which is 6, and you put it in front of carbon. You then take the number 8 and you put it in front of hydrogen. Then you have to find your total amount of oxygen. 6 times 2 is 12. Plus there are 8 more. That equals 20, but you must divide it in half, so that's a 10. 2, 10, 6, 8 is the chemistry. Now, I'll work through this the shorter way. Once again, if the short way doesn't make sense to you, then don't do it. Do it the long way. So the shorter way, we are going to go straight across here, which means there's only one step. So that means there's only one vertical line. I take my unit, 10 liters of propane. Now, when we do it this way, the units don't cancel the way they normally would because we didn't go the long route. So it'll be fine if you just write what the units are. How many liters of carbon dioxide? So now we use the ratio of coefficients. We put the moles of my given on the bottom, and there are 2. I put the moles of my wanted, which is CO2, on the top, which is 6. So now there's all sorts of stuff we can reduce here. 6 over 2 is 3 over 1. So what's the answer? $30. What do you think? You do the ones above it. You can do it the short way or the long way. It doesn't matter to me. Take about, 7 minutes and try and do those last 2 problems. All right, 1 second, Wiley. Okay, please look at the screen. A lot of you are not paying attention today. That will be detrimental to your grade. Every single thing in this problem ends up canceling out. Now, it's a long setup. I did it the long way. If you did it the short way, these just wouldn't exist. You'd end up with 12 over 12, which reduces to 1 over 1, and that would cancel out too. So really, in this, since we compared something with the same coefficient, it just ends up that the answer is the same as the given. All right, how many of you had 25? Raise your hands for me. Okay, good job. All right, the last one, N2 plus O2, and it makes nitrogen monoxide, so just NO. Give that your best shot, and then we'll move on to some notes. All right, so our reaction basics. So it turns out pretty much reactions, whether they happen or not, is all about energy and what's favored in this world and what is not favored in this world. If a reaction happens, it's because the reactants are more stable or they are favored more, or sorry, the products are more favored than the reactants. All those seniors. So here we go. Energy is the ability to do work. More simply, it is stored work or work in action. You're just all writing blanks. I'll wait until you're done, then I'll just pretend you're listening. Swimmer's cough. Every year it gets you guys. Okay, so kinetic energy. The very first lab book of all of chemistry, we studied the kinetic theory of matter. I'm sure you all remember that. Kinetic energy is energy something possesses because of its motion. Kinetic means things are moving. It is the energy of motion. The faster the velocity of an object, the more kinetic energy it has. Yada, yada, yada. Moving on. Potential energy is the amount of energy stored in something because of its relative position. Yada, yada, yada. There are several types of ways to express energy. Some examples are. Okay, so first off, our kinetic energy and our potential energy in chemistry is potential energy, you need to pretend is like a log of wood. It's just sitting there doing nothing, but all of the stuff in that wood is bonded together. If I light it on fire, those bonds break, and when they break, they release kinetic energy as heat. So in chemistry, bonds will store energy that they then can release through heat and light. Are we kind of all right with that? All right, now, that log, it didn't just have energy. Where did it get its energy? No, from the sun. So really, when you burn a log, you're taking like the 20 or 30 years of stored up sunlight energy and releasing it in a short amount of time. Okay, that's all you're doing. You're converting solar radiation into infrared radiation, which you feel is heat, and then you see some as light. All right, and it's just the breaking of bonds. The sun's energy goes into making bonds, and then we light it on fire to break the bonds. All right, there are several types of ways to express energy. I think you got those, so we'll move here. Did you get the first? Well, I guess I have to go back and read them first. Whatever, here they are. The first is chemical. That's the energy stored in chemical bonds that can be released with the change in electron orbitals. Oh, that's a lot of words. Mechanical energy, that's the ability to do mechanical things, such as raising or lowering, expanding or contracting. When you drove your car here today, when you drove your car here today, you used chemical energy to produce mechanical. You took your gasoline, C8H18, which is called octane, that's where the 8 comes from, and you reacted it with oxygen in a combustion reaction, and it produces heat, it produces an explosion essentially, and then you have like a piston in here, they spray the gas in here and it explodes, and it pushes your piston up, which then comes back down due to some, I don't know all the details, but it goes up, the other half is going down at the same time, and it's just an explosion over and over and over where you're lighting that on fire. And that is connected through all the shafts and everything, and that turns your wheels on your car. That's my beautiful car drawing. That's an SUV. It's a Kia Sportage. You kind of all right with that? It's just a chemical reaction that's causing something to move up and down. And we as a human race have figured out to take something that's moving up and down and convert it into wheels that roll so that our lives are easier. Who's okay with this so far? All right, you don't really care. Nuclear, that's when matter is converted to energy. We don't really study that a whole lot in this class, but this equation is the Einstein, E = mc². So it's where matter is converted to energy. All right, then electrical is expressed in the flow of electrons from one place to another. Did anyone listen to their radio on the way to work today or school today? All right, use your headlights. Did your dashboard illuminate? All right, then you also took chemical energy and produced electrical energy. Because as this process happens, this thing's still going up and down because of a chemical reaction. You all right with that? That's turning wheels, but if you like zoom in on this, then there's like these black things that seem to always break in my car. They're called belts. And one of those belts connects to your alternator. And what does your alternator do? Anyone know? It alternates. It takes mechanical energy and converts it into electrical energy, so that you can have the power on in your car. You can use the headlights, the radio, everything comes on because of the alternator. It's a super important part of your car, but really it's just part of this mechanical that came from the chemical energy. Are we okay with that? All right, then there is electromagnetic energy, and that is when energy is in the form of electromagnetic radiation such as visible light. All right, we used electrical energy to produce electromagnetic radiation. That's the lights that are given off. And then heat. Does your car give off any heat? Yeah. It turns out, by the way, your car is a better heater than it is a motor. Most of the energy from cars are getting better, but most cars, most of the energy from burning the gas just goes to heating up your engine. It doesn't even go to mechanical energy. We lose over half of the efficiency when we burn gasoline. All right. Now, cars are getting way better, so it might not be over half anymore. But look, all of these except for nuclear were experienced as you drove yourself to school, or you rode a bus, or your parents drove you. If you walked, then most of that was not involved. You did, well, I'll shut up. You don't, whatever. No, you don't want to. All right. All chemical reactions involve some sort of energy changes as the bonds change between the atoms. Sometimes energy is given off. That means potential energy is released. We have a name for that. Anyone remember this? Given off? Oh. The next letter will give it away. Maybe it won't. Exothermic. Exercise. I like that guess. Thank you. When energy is released, we call it exothermic. When energy is taken in, we call that endothermic. We've heard of those. They were tested on like multiple tests in a row. Are they tested on this one? They're not. All right. That's the bottom of that page. We're done with that page, right? So the next page. All right. There are 6 evidences of chemical reaction. We've talked about them in 2 other lab books. This is your 3rd. So, energy changes are evident in chemical reactions when potential energy in chemical bonds is changed in the following manners. So, the first way is that light is given off. Potential energy from valence electrons is released in the form of light. So, on the exam, there's like 5 questions. They're not that hard, but they are a little bit tricky. It's going to tell you something, and then you have to indicate whether it's giving you evidence of a chemical reaction. And then if it's a yes, you have to label which one. So, for instance, if it says like something is glowing when it reacts, is that evidence of a chemical reaction? Yes. And then which one? The light was given off. You okay with this? All right. Next one. Gas or bubbles are given off. That indicates an increase in kinetic energy. I'm not going to read that whole sentence, but things are moving faster if they're in the gaseous state than the solid state. All right. This is how we take chemical and turn it into mechanical energy. It's the expansion when reactions happen due to gas formation. All right, electrical potential, that's voltages. It's released, is the release of chemical bond energies to cause the movement of valence electrons. And that's batteries. That's what your phone's running off of right now. All right, temperature changes. We talked about this already. Endo and exothermic. Because thermic really means temperature. So on this slide, I kind of lied. I should have said, and it won't matter, endogonic and exogonic, whatever. That means energy, that means heat, but we don't use those terms in this class, so it doesn't really matter. But they are slightly different. All right, so when heat is released, exo, taken in, endo, and then a precipitate is formed. On the exam on Friday, the precipitate is hard to write without just describing exactly. So the key words you're looking for is that the solution, it becomes like cloudy, and that some of it settles. That's the sign of a precipitate. And remember we made a precipitate in the examples? This is from when I did the demonstrations. That's all the precipitate that's left. And then we also did it in that one lab, the bottle bewilderment. You added stuff, and went grello, yellow, orange, gold, and brown. Those were all precipitates. So in that question, I have to be careful because I don't want you to know that it changes color. So I just say that it becomes cloudy and some of it separates to the bottom. That is a yes, a reaction happened, and the evidence is a precipitate was formed. Okay? Then, a precipitate, remember, is when two liquids react to form a solid. All right, and then a color change, and really it's an unexpected color change. And remember that for the exam. It can be from increasing or decreasing the potential energy stored in the dumons being formed. Color's super complicated, but what we're doing in a reaction that produces color is we're changing the way their electrons bounce up and down. Are you all right with that? Okay, I'm going to tell you a test question right now. There's two of them. So pretend you have a flask right here and you have some baking soda. You okay with that? There are two questions that involve this same reaction. One of them says you add vinegar to baking soda and it starts to bubble. And the question will say, is that evidence of a chemical reaction? And you would say, yes. And if I asked you which one, you would say, a gas is produced. Are we okay with that? All right. Another question says, it's the same thing. Vinegar is added to baking soda and the solution is white. Is that evidence of a chemical reaction? No, it's not. What color is baking soda? White. Vinegar is a clear liquid. Put them together and the solution should be white. Are we okay with that? So just that it turned white, that does not mean a reaction happened. Now, we know a reaction happens, but not because it turned white, because it bubbled. Are you okay with that? All right. Because if I put flour and water together, there's no chemical reaction, but the solution is what? White. Are we really okay with that? Because it's really one of the more missed questions in the entire exam. That it is not an evidence of a chemical reaction. Okay. Oh my. This can't be true. Like we started this a year ago. And now we're finally done. The year ago jokes never get old in early January, do they? I don't know. Shani's just giving me attitude right here. Have you actually ever given anyone attitude in your entire life? Probably your mom or your brother. Okay, we are done. And we have, what, 7 minutes left? Okay. Tomorrow we're going to mostly review